what we are going to learn today is something that is used quite often. And this questions for product rule, questions of chain rule, all of them can come into exam one, could be the first or the second question. Most of the time, if you notice. Product rule just tells me that if you've got a function which is a product of two functions, then the differential of this function is basically the first function times the differential of the second function plus the second function times the differential of the first function. It's as simple as that, right? Nothing beyond this. We'll not cover what and how's, why we've landed here. And if I have to write it down in terms of dy by dx, so if I say if my y, a function y is a multiplication of two functions u and v, then my dy by dx is u times dv by dx plus v times du by dx. That's the product rule. All right. So in its very, very simplistic example could be, think of a function, let's say y equals to 2x times x plus 1. Let's say you've got something like this, right? Now the one way is I open the bracket up and solve them individually as a differential, easiest way, because this is very, very simple. The other way could be, I say dy by dx is the differential, I'll write this function as is, times, what will be the differential of x plus 1? 1. Plus x plus 1, what will be the differential of 2x? 2. Let's solve it. So this becomes 2x plus 2x plus 1, which is 2x plus 2x plus 2, which is 4x plus 2. If I open this up, generally, this would have been 2x squared plus 2x, right? So if I want to differentiate it individually, this would have been 4x plus 2 anyway, no? You see, you've got the same answer. Does that make sense?
Yeah.
Very, very simple. Now use all of that now to differentiate. Let's say you've got y equals to 2x squared plus 1 times 5x cubed plus 16. Can you find the dy by dx of this function? So you've got 2x squared plus 1. So let me just write that as is. Now trying to find y dash. So first function as is 2x squared plus 1 times the differential of this function. What is the differential of this function? 15x squared. That's it? That's it? Aishka, did you get that answer?
Yeah.
Plus, Romel, here.
Yeah.
What's the differential of this function? 4x
Yeah.
times this bit. So I say 5x cubed plus 16 times 4x. And then you just expand it and pick the like terms up. Aishka, did you get it?
Yeah.
Correct? 100%? Did you get it, Romel?
Yeah.
Yes or no?
Yeah.
All right. Let's try one more. So I say y equals to x raised to the power of minus 3 within brackets 10 x square 5x 5 raised to the power of 3. Find the y dash, please. And I'll take here, or what needs to be used here, what was not there in the last example that we did.
Chain rule.
Good job, chain rule. You just need chain rule. So this derivative is easy peasy, right? Minus 3x raised to the power of negative 4. Good. But here, Romel, there's that pinged your mind saying that you need to use chain rule here?
Yeah.
And did you use it?
Yeah.
What is the answer?
I haven't got the answer yet.
You still need to work it out?
Yeah.
1 more minute? Or 1.5?
I haven't answered yet.
Go for it. Chris, you done?
Do we need like, can it be in the long form or does it need to be simplified?
It has to be simplified, factorized form.
Okay.
You done, Chris?
No. I know it's chain rule, but like, how do you do it? I don't know how to do it.
Last week we did that, right? Now, but are you sure that you need to use chain rule for this bit? First things first. The thing that should strike to your mind is, okay, this is easy, straightforward. N raised to the power of x of n minus 1. Here is a chain rule. Did that strike your mind?
No.
Why? I told you, whenever you have an expression encapsulated in a power, it is blindly chain rule. Blindly. Plug this as another function, and then what was your chain rule? If f of x is g of h of x, this is what the chain rule is, right? Function within a function, right? When you say h of x is u, right? And then what is f dash x?
U cube.
If I were to write it in the Leibniz notations, it is dy by du times du by dx. My dy by dx is. So, if it's still not making sense, this bit, the challenge is finding the differential of this. Let this stuff be u. Let's say this is what? Maybe z, right? So then z equals to u cube. Nod your head yes or no. I don't know, right? Then what is dz by du? 3 times u square, right? And what is u? U is 10x square minus 5. Can you not find du by dx, which is 20x? Now you multiply the two. So you said 3u square times 20x and sub u in. U is 10x square minus 5 square times 20x. Right?
Yeah.
Yes? Now, one thing that and then you simplify that, and probably that's the answer right on the screen here. Right on your screen there. All right? Now, the thing that you need to note, one thing that I want to just bring to your attention here. Shall I take this off?
What happens to the x of the
Sorry?
remove
that's
the
fine.
solution.
Take your side. Yeah, you were asking something.
What happens to the thing of the x? The one in front, yeah.
This
that
one?
Yeah.
You mean, see, I just explained you how the product rule still stays there, right? Product rule still stays there. So you still have to solve it.
Yeah.
Right? I just gave you this bit here. an elongated explanation. Sorry, we've got a new joiner here. So what's your name?
Ran.
Come again.
Ran.
Ran.
Ran, yeah.
Okay. So Ran, we're doing differential. We're doing calculus, chapter 9 of the differentiation of the Cambridge book. Which book is used in your school for methods?
I have it online.
Yeah, so do you know, is it Cambridge book or it looks very similar to this or what?
No.
No?
No, it's different.
What chapter you're doing so far?
On chapter 3.
Which topic? Do you know the topic?
One sec.
Anyway, till the time you get your stuff out. So one thing that we need to note here, Aishka, here. And Ryan, here, okay, that's fine. Let's say you've got to solve the same story here, but then it is just this. Let's say if it says f of x is 10, what was that? 10x square minus 5 whole cube. Let's say if you're asked this question to be solved in your exam. So what you're going to do is, this question can come in two ways. One, it could be a 1-mark question, or it could be a 2-mark question. When it is a 1-mark question, no one is interested in looking at your steps. I mean, interested, yes, people are, examiners are, but if you don't even give it to them, that's fine. You're fine to see the final answer. In its very simplicity, how your chain rule works is, pick up this expression, and Romel, this is for you, pick up this expression, write this expression as is, reduce a power here, minus 1. 3 minus 1 is 2. And find the differential of the stuff inside. What is that? 20x. So the final answer is 20x 10x square minus 5 whole square. This is chain rule in just 2 steps.
What are 3?
Sorry?
Mention it, the 3.
Did I do something wrong? Ah, sorry. Yeah. No, that. So it's 60. 60x. Simple. If you write this answer straight away, you get full marks. Okay? Got it?
Yeah.
100%?
Mm-hmm.
Guys, do you want to try one more?
Yeah.
One more? Probably try this one. Ex, e raised to the power of x, 2x square plus 1. Can you find, and this should be straightforward. Why am I saying that we shouldn't be using a chain rule here?
Because
There's no
power.
whole power there, right? So you don't have anything here. So that takes off. This is very, very simple question, right? Romeo, did you get it?
Yeah. I was just looking, I forgot how to differentiate and the explanation.
Come on. Differentiate, pop the first function as is. Differentiate this, which is 4x, right, plus, write this as is, and obviously the differential of e raised to power x is e raised to power x, so you write this as is. Yes? And then you solve it and open that up. Right? You can take e raised to power x as a common factor, and you can say 4x plus 2x squared plus 1. That's your y dash. Make sense? Make sense. Aishka, how will you differentiate? Do you need a chain rule there?
Which one?
Chris, do we need a chain rule here?
Yeah.
Chris, yes or no, straightforward, or I don't know. You've got 3 choices.
I don't know.
Alright, cool. What about you,
Yeah.
Romel?
You raise it to the power of half.
Good job. That's what you were about to say, right? So Chris, we've got a power of half here. X minus 1 raised to the power of half.
Yep.
is what it is, right? So you need to apply chain rule.
So anything with a power, you use chain rule.
Sorry?
Anything with a power.
An expression with a power, chain rule. That's how it is. It's as simple as that. Okay? Alright. Then comes your quotient rule. And questions for quotient rule can also come in the exams. As in just to apply quotient rule directly and give the answer. And all of that needs to be in your bound reference, should I say. So, quotient rule. And I keep doing quotient rule. What is quotient rule? So, if you have a function f of x, and Ryan, you understand functions?
Yeah.
Which is a fraction where you've got one function sitting on the top versus one function sitting at the bottom. Could be x square over x square plus 1, something like that. Right? So here and here. Right? So if you've got something like this, then what is f dash x? It's very, very standard. Just need to remember that. So that will be the bottom function. See, the denominator is always the square of this function. Don't write x square inside. That's a crime to do. Right? So that will be always here. And on top you have the bottom function times the differential of the top function minus the top function times the differential of the bottom function. That's about it, pretty much. Okay? So if I were to say, alright, can you do x, let's say your function y is x minus 2 over x minus 2 over x square plus 4x plus 1. Can you quickly find the derivative with respect to x? Quickly, can you find me the y dash? You're tempted. Okay. Tell me, what's the answer?
Negative x squared plus 9 over x to the power 4 plus 4x squared plus 1.
Oh, good.
Oh, is it?
That's what you have? Yeah?
Oh, I didn't get plus 4x there. What about negative x squared plus 9?
Either you get 100% or you don't get it. But then if you've shown steps, and this is a 2-mark question, you'll still get 1. If you've applied your quotient rule correctly. So this bit here is basically squared. Chris, did you get that answer? Good. This bit, Ayushka, 4x plus 1 times the derivative of x minus 2 is 1, right? Minus x minus 2. What's the derivative here? 2x plus 1 times the derivative of x minus 2 is 1, right? Minus x minus 2. What's the derivative here? 2x plus 4. And you solve it, you get negative x square plus 4x plus 9 over x square plus 4x plus 1 whole square. Aishka, did you get it?
Mm.
What was not correct that you Did not apply. Did you do this first step?
Yeah,
Was
but
this in your numerator?
the steps are correct. I just like did it. I just got mucked up in the calculation.
This will be a non-CAS question that will come to you, right? This is what is expected, right? Don't muck up with algebra, please, right? You'll lose marks, right? All good? Make sense?
Yeah.
And then any function in the world can help you out. Let's say if I've got, let's do one more. Let's say y equals to sine x over x plus 1. Come on, circular functions. Go for it, please. X plus 1 whole square, yes, that's the denominator is sorted out because that's the whole square, correct? Romel?
Yeah.
Write x plus 1 as is. What's the differential of cos sine x? Cos x minus, write sine x as is. Sine x, and what's x plus 1 is 1. That's it. That's the answer. Aishka, did you get that? Why? What was difficult here? Come on, tell me. What made you think here? This is a very straight application, no? I didn't do any magic here. Did I? So, what was the problem? Tell me.